Hello, we're going to talk about the homogeneity hypothesis testing situation. You should have already read chapter 15 from the book. Our scenario is, do Republicans and Democrats feel differently about how to fix the economy? I asked 100 Republican voters and 100 Democrat voters, what will have the biggest effect towards fixing the economy? Reduce taxes, cut spending, tax the rich, or more business legislation? And then the results are given. So we first need to determine the appropriate test situation. And so we have two samples, the 100 Republican voters and the 100 Democrat voters. We have one variable. What will have fixed effect to fix the economy? And then the level of measurement is categorical. Because there's no way I can objectively order the outcomes of reduce taxes, cut spending, tax the rich, or business legislation. And so because it's two samples, one variable, and the level of measurement is categorical, that's how we know the test situation is homogeneity. And then the other good thing to know from the scenario is this is my question of interest. The question that we are trying to answer. And so we know the test situation is homogeneity. And so the next thing we need to talk about are the hypotheses, the null and the alternative hypotheses. Now, there's no notion of the hypotheses and symbols for the homogeneity test situation. We just write them in English. And initially, you might think, oh, well, I'm really comparing these outcomes to one another. But that's not what we are comparing here. What we're really comparing is Republican versus Democrat. And we're using the variable to make the comparison. So the two things we're comparing is the population of Republican voters and the population of Democrat voters. And we're using this variable to make the comparison. So there's no notion of comparing the outcomes to one another. We are comparing these two populations. And so how we would write those hypotheses is Republicans' preference for the biggest effect to fix the economy is the same as Democrats' preference. And so what we're saying here with them being the same is this notion of equality. And so it's not that the outcomes are equal to each other. It's not that the number of people who want to reduce taxes and cut spending is the same, but it's if Republicans want to reduce taxes the most, then Democrats also want to reduce taxes. So whatever that preference is the same for Republicans and Democrats. It doesn't mean that all of the outcomes are equally likely. It just means their preferences are the same. And then for the alternative hypothesis, Republicans' preference for the biggest effect to fix the economy is not the same as Democrats' preference. And so really we have this notion of Republicans' preference or attitude or belief on the variable fixing how to fix the economy is the same as Democrats. That's the null. And then Republicans' preference, belief on the variable how to fix the economy is not the same for the alternative hypothesis. And so for homogeneity, we have no notion of a greater than or a less than alternative hypothesis because we're using a categorical variable to make the comparison of these two groups, Republicans and Democrats. And with a categorical variable, there's no ordering of the outcomes, so there's no notion of bigger or smaller. We can just say they have the same preference, they have different preferences. And so now that we have the test situation and the hypotheses, we can get to the critical value. And to get to the critical value, we need delta, the degrees of freedom. And so what we look at is it's the number of samples minus 1, that quantity times the number of outcomes minus 1. And a nice way to see this is we see this in the observed frequency table here, that there are 2 rows. Those are the 2 samples, and there are the 4 columns for the 4 outcomes. And so one way you can think about this is it's the number of rows minus 1 times the number of columns minus 1, which is the same thing as the number of samples minus 1 times the quantity, the number of outcomes minus 1. So in either case, the degrees of freedom are 3. So then we come down, and for homogeneity, the null distribution is a chi-square. And so we know we're going to use the chi-square table because the null distribution is chi-square. We go to 3 degrees of freedom. Alpha is 0.05. So my critical value is the 7.815. So if we draw a number line, we have 0, 7.815. If my test statistic is bigger, that's when we reject the null hypothesis. Now we can move on to calculating the test statistic. And so first we look at this O table, or the observed frequency table given here. And we see, and we need to talk about what these frequencies mean. And so this 5 right here means of the 100 Republicans, because it's in the Republican row, 5 of them want to tax the rich. And then similarly, we have 7 right here. Of the 100 Democrat voters that are in that sample, 7 of them want to cut spending. And so we've talked about frequencies before, and these are now just the observed frequencies. And so to calculate the test statistic, the equation of the test statistic is it's the sum of the O minus E squared divided by E. And so we're going to have to create a table for the expected frequencies, and then the O minus E table, and then finally a table for O minus E squared divided by E, and then take the sum of that. So the question is, how do we create this expected frequency table? Here. Now, a pro tip so that you don't mess up is always keep the column orders the same and the row orders the same. Make your life easier. So how we get the expected table is we have to use what are called the marginal sums. And so we start with the O table, and we look at this 70, or excuse me, this 47 plus this 17 equals 64. So I just added those two numbers and got 64. And then add the next two numbers, and I get 40. I add the next two numbers and get 58. And the last two sum to 38. And those are referred to as the column marginal totals because it's the sum of each of the columns. Well, then we can also do the row marginal totals. So I take the 47 plus 33 plus 5 plus 15 and get 100. I take the 17 plus 7 plus 53 plus 23 and get 100. Now, why did those equal 100? Because that's the sample size, and the sample size in each of the two samples is the same in this case. The sample size does not have to be the same, but it is in this example. And then the last marginal total is what's called the total total, and that's the 100 plus 100, which gets you 200. Or you could do 64 plus 40 plus 58 plus 38 is also equal to 200. So we have the column marginal totals and the row marginal totals and the total total. And so how we get the E value for this cell right here for Republicans and reduced taxes is we take the column total times the row total and then divide it by the total total. And so when you do that, you get 32. So we're going to put 32 right there. And we're going to do the same process. So for the next one over, it's going to be the 40 times the 100 divided by the 200 is going to give me 20. And then the 58 times 100 divided by the 200 is going to get me 29. And then 38 times 100 divided by the 200 is going to get me 19. So in all cases, we're taking these column totals here times that row total matching up and dividing it by the total total. That's how we get the expected frequencies. Now, because the sample sizes are the same in each sample, then both of these rows are going to be the same because again, it's going to be 64 times this 100 divided by 200. So I'm going to get 32, 20, 29, and 19. And you'll notice that 19 plus 19 equals 38, 29 plus 29 equals 58, 20 plus 20 equals 40, and 32 plus 32 equals 64. So the marginal totals from the observed frequency table are the same as the marginal totals of the expected frequency table. And so what's happening here is we observed 47 Republicans saying we need to reduce taxes, but under the null hypothesis, under Republicans and Democrats having the same preferences, we would expect 32 Republicans to say we should reduce taxes. And so you notice this expected frequency, them being the same, is under that notion of the null hypothesis of their preferences being the same. So the outcomes, 32 is different than 20. And so we're not comparing outcomes, but the row for Republicans is the same as the row for Democrats. And that works out nicely when we have the same sample size here. Now, if you have different sample sizes, these two rows are not going to be the same, but they're going to be, this is what equality would look like for differing sample sizes. And now We continue on with the test statistic and create an O minus E table. Again, keeping everything in the same order. And now what we're doing is we are just matching up. So the 47 and the 32, the 33 and the 20, the 5 and the 29, the 15 and the 19, the 17 and the 32, the 7 and the 20, the 53 and the 29, the 23 and the 19. We're just matching everything up cell by cell and doing the subtraction. And so 47 minus 32 is 15. 33 minus 20 is equal to 13. 5 minus 29 is equal to a negative 24. And 15 minus 19 is equal to a negative 4. Now notice if I take 15 plus 13 plus a negative 24 plus a negative 4, I get 0. And so the marginal totals of the O minus E table are always going to be 0. And so I can use that and I go, well, if 15 plus something has to equal 0, this has to be a negative 15, negative 13, a positive 24, and a positive 4. And so that's how you calculate the O minus E table. And then the last table is where we have O minus E squared divided by E. Republican, Democrat, reduce taxes, cut spending, tax the rich, business legislation. And so we're still doing things matching up. And so this first cell right here, well, it's this O minus E is this 15, but it's squared. And then we got to divide it by the corresponding E value, which is 32 in this case. And so when you do that, you get 7.031. So this is 7.031. And then when we continue that exact same process, we're going to take the 13 squared divided by the 20. And we're going to get an 8.45. Then we're going to take the negative 24 squared. So when you square that negative 24, it becomes positive. Divide it by the 29. We're going to get a 19.862. And then the negative 4 squared becomes a positive, and then we're going to divide it by the 19. We're going to get 0.842. Now, the nice thing is, because we have equal sample size, this next row is going to be identical because negative 15 squared divided by 32 is the same thing. So again, the test statistic is a little bit easier because of the equal sample size. If you do not have equal sample size, this nice thing of these two rows being the same is not going to happen. So be aware, we have equal sample size. That's why it works out nicely. And then the last thing we do is I take all of the values in this table and I add them up. So the test statistic is equal to 7.031 plus 8.45, et cetera, for all 8 of those values. And when we add up all of those values, we get 72.37. And so that is how we calculate the test statistic for the homogeneity test situation. Again, things worked out nicely because we had equal sample size. If you don't have equal sample size, it's going to be this row is not going to match, and this row is not going to match the row above it. And so now that we have the test statistic value, we can compare it to our critical value. And so we would reject the null because 72.37, which is my test statistic value, is greater than the 7.815, which is the critical value. So my test statistic is bigger than the critical value. That's why we reject the null hypothesis. And so when we reject the null hypothesis, we conclude the alternative in English, and then we need to look at the O minus E table. And so when you reject the null hypothesis, you look at the two largest O minus E values. And so this is why when you're calculating the test statistic, we cannot skip the O minus E table. And so when I look at this, this is my largest O minus E value, and this is my next largest O minus E value. And so we're going to use those to make our interpretation. So right here, I conclude that Republicans' preference for the biggest the biggest effect to fix the economy is not the same as Democrats' preference. And so right here, that's the alternative in English. And so we're concluding the alternative in English, but now we need to get more specific. So we said they're different, and now we're giving some indication of how they're different. Well, these two largest O minus E values here are about Democrats preferring to tax the rich and Republicans preferring to reduce taxes. And so that's why we say specifically Republicans prefer to reduce taxes to fix the economy. So that's coming from this guy right here. And Democrats prefer to tax the rich to fix the economy. And that's coming from right here. So we're using those two largest O minus E values to give more detail for our conclusion. But we only do that because we rejected the null hypothesis. If we'd happened to have failed to reject the null hypothesis, we would have just concluded the null that they're the same, and we would have been done. But because we rejected the null hypothesis, we conclude the alternative in English, and then we interpret the two largest O minus E values.